Okay, so here we have a question about what is the greatest number of particles, and you have a choice of A, B, C, and D. Now, the question, you have to look at what it says. Everything in the question is meaningful and important. So over here we say, which sample measured at room temperature and pressure? Now, room temperature and pressure should already put a light bulb moment in you. Contains greater number of molecules. So let's have a look. We're looking at hydrogen molecules and helium molecules over here, as you can see. And so we need to say, okay, well, 1 gram of hydrogen molecules. Okay, we've got molecules here, so we know that that's going to be H2. Helium atoms is just going to be He, so just one of them, compared to H2, where there's 2 of them. That's interesting to me. 1 decimeters cubed. Now that's a volume. So the volume equals 1 decimeters cubed. And so the first thing I'm thinking about is, right, let's think about moles. I've got 1 gram and I've got 2 hydrogen molecules. So 1 over 2, because 2 is the molecular mass of hydrogen, 0.5. And the 1 gram of helium, helium has a molecular mass of 4. So He equals 1 divided by 4, because 1 gram divided by 4 molecular mass is 0.25 moles. So already I know that this one has a greater number of molecules. I know that because remember the definition of Avagadro is basically 1 mole of a molecule contains 6.02 times 10 to the 23 particles. So what that means now is, therefore, if I times this 6.02 by 0.5, I know that that's a bigger number than He. So this one is a plausible answer so far. Now, in terms of decimeters cubed, well, there's a definition that I need to know from my A-level chemistry, and that is that 1 mole of any gas occupies 24 decimeters cubed of volume. So 1 mole occupies 24 decimeters cubed of volume. Now the problem here is, if you've got 1 decimeters cubed, that's going to be way more smaller than 1 mole. So we're going to have a number which is much less than 1 mole. Okay, and the same thing applies over here as well for the helium atom. So these two are not feasible. This one is smaller than that one, so therefore the answer for the first one has to be A. Okay, so in this question, slightly easier, you've got to find the number of molecules in a cylinder. It says over here, a gas cylinder contains 5 grams. Very important information. You've got the mass, and you want to find it for propane. Now, propane are molecules in the cylinder, and they have a Avogadro's constant given to you, which is 6.022. So the first thing you need to do is make sure you understand that propane has the formula of the general alkanes. So if I pop in my propane, which is C3, and 2 times 3 becomes 6, 6 plus 2 is 8. So it's C3H8. Work out the molecular mass of that first of all. So the MR is going to give you 12 times 3, which is 36. 36 plus 8 is 44. And then you times that number by the Avogadros. So it's MR times the Avogadros, which will give you the number of particles. Okay, right, so that doesn't look very nice, does it? Let's do that again. So number of P. So P in the circle just tells me that a symbol way of saying particles. And so now I'm going to put that in my calculator, and I should, well, let's just do that with my good old Google calculator here. And we're going to write down 6.022 times that by 44, didn't I say that? And that gives me an answer of 2.649. Oh, actually, oh yes, we forgot something, haven't we? Okay, so in this question, it says a gas cylinder contains 5 kilograms of propane. How many propane molecules are in the cylinder? So over here, we need to make sure that we see this question here and think, okay, 5 kilograms means mass, and propane is the substance that we need. In this question, we need to know how many particles there are, so how many molecules of propane are there. We've got Avogadro's constant, so that's an easy calculation, hopefully, where we have to find the number of moles, times it by our constant, and we'll be able to find our number of molecules. So let's do that. So propane, you should all know that it is a alkane, so it has the formula CnH2n plus 2. And so that means that we have to do C3, because this propane. 2 times 3 is 6. 6 plus 2 is 8. 12 carbons times 3 is 36. 36 plus 8 gives me a molecular mass of 44. Now, don't forget, it's in kilograms, so quickly do that in your calculator and turn that into 5,000 grams. Divide that by your 44 and get your answer. And so I'll quickly do that in my calculator. So 5,000 divided by 44 gives me 113.63. 113.63. And then you've got times that by our L. So your number of moles multiply by your L will give you the number of particles or substances or whatever it is. It could be electrons, it could be particles, it could be molecules. In this case, in fact, in this case, it's going to be molecules, isn't it? So let's do that. So in your calculator, if I've got my calculator over here, I've got an answer, and I will just, in fact, I'll show you guys how to do this on the calculator so you can see for yourself. Let's move this along. So 6.022 times 10 to the 23 times that by our answer of 113.63. 113.63, and there we go. We've got an answer of 6.8427 times 10 to the 25. And of course, looking at those ones, 10 to the 22 isn't correct, and 7.22b isn't correct. 6.8 times 10 to the 25 is correct. So let's write that down and circle that. There you have it. Okay, so this question is a little bit more tricky because there's lots of information that you have to read. First of all, CCl4 is an effective fire extinguisher, but is no longer used because it is toxic and its role of depletion of the ozone layer in the upper atmosphere. So a bond CCl4 breaks and a reactive species is formed. And one of these is a small molecule called freon. Freon CF3Cl has a mass of 1.78 times 10 to the minus 4 kilograms, and it escapes from a refrigerator into a room which has a volume of 100 meters cubed. Assuming that the freon is evenly distributed throughout the air in the room, calculate the number of freon molecules in a volume, and it occupies a space of 500 centimeters cubed. So lots of information there. What do we do first of all? Well, the first thing is we always work out what we already know. And in this question, we know that we need to find out the freon molecules, and we have already the mass of it. So let's underline that, very important. And we also have enough information to work out the number of moles. So let's do that. So first thing is to work out the molecular mass of CF3Cl, and the MR of CF3Cl can be worked out on a calculator. 1 carbon plus 3 fluorines and 1 chlorine look at your masses on the periodic table, and it will give you a mass of 104.5. The mass is in kilograms here, so we'd really like to have it in grams because that's our unit to work out the number of moles. And so we're going to do that. So the mass is 1.78 times 10 to the minus 4 kilograms. Let's times that by 1,000, and you should get 0.178 grams, right? So we've got our grams now. So let's work out our number of moles, which is N. So 0.178 grams. Divide that by 104.5. And that should give us our molecular mass. So let's work that out quickly. That gives us an answer of 0.00170. 0.00170. Okay, thank you. So 0.00170. And now we've got our number of moles. We have the next piece of interesting information here. So the volume is a room of 100 meters cubed, but we've only got a occupied space of Freon molecules of 500 centimeters cubed. So we have to use both of this information. The first thing you do is you would first find out the volume of that in decimeters cubed. But because we've got that in meters cubed, we should keep the units the same. So usually you might use decimeters cubed, but this time you're going to turn it into meters cubed. So be careful here. So the conversion is 1 centimeters cubed is 1 times 10 to the minus 6 meters cubed. Okay, so let's do that. Let's work out the answer. So we're going to have to do the following. So 500 centimeters cubed multiplied by 1 times 10 to the minus 6, which will give us our answer. And let's work that one out. And that gives us 5 times 10 to the minus 4 meters cubed. So 5 times 10 to the minus 4 meters cubed. Now we've got our number of moles over here. We need to times this by our Avogadros to get the number of molecules that are in the Freon molecules. So let's do that. So we do 0.0017 times that by the Avogadros, which is 6.02 times 10 to the 23. And that will give us an answer of, so 6.02 times 10 to the power of 23, and multiply that by 0.017. Give us an answer of, actually 0017, sorry, isn't it? That's better. And that gives us an answer of 1.0234 times 10 to the 21. 1.0234. Let's write that down. So we're nearly there now. Let's just scroll a little bit down a little bit so we can do this and have a bit more space. So we've got the volume that it occupies. And of course, it's in a volume of a room of 100 meters cubed. So we need to times our 1.0234 multiplied times 10 to the 21 by our meters cubed volume, which we found earlier on. So times that by 5 times 10 to the minus 4. And then we have to divide the whole thing by 100 meters cubed, because that's what the volume of space we have. So 100 meters cubed. So 5.117 times 10 to the 15. And let's look at the number of significant figures. It says an appropriate number of significant figures. When they say appropriate, just consider that to be 3 significant figures, which is good enough, or even 2. So over here, 5.1 looks pretty sensible to us, so we can do that. So let's write that down. So the final answer then is 5.1 times 10 to the 15 molecules. All right, there you go.